so this problem is called the quadrature of a lune, and what we have is these two lune shapes here that kind of look like moons, and we can show that the area of those shapes actually equals the area of a triangle, which is kind of interesting that those circular shapes can be made into what's called a rectilinear area. So, okay, fine. So what we have is this guy here is a semicircle with a triangle inside it, and then we have two semicircles off the edges of this triangle. And so what we would love to show is that this shaded area equals the area of the triangle. Well, I can find my shaded area, by taking the entire area, the area of the entire figure, and subtracting out this semicircle here. So the shaded area of those lunes, the shaded area is going to be the total area minus the semicircle ABC, right? You take the whole thing, take out that chunk, you'll have what's left. Now if I want the total area, I can get that by adding the triangle plus these two semicircles. So I can take the triangle plus this semicircle plus that semicircle, and I'll have the whole thing. So I'll have triangle ABC plus semicircle ADB plus semicircle BEC. That's the total thing. And then remember I have to subtract, to get the shaded area, subtract out semicircle ABC. Okay, so now let's give this some variables. I want to call the radius of this circle here A, so I'll have A and A. And I'll call the radius of this semicircle B, so I'll have B and B. And the radius of the big semicircle C. So now, just rewriting this, I have I'm still going to call triangle ABC, and ADC, oops, that should be ADB, shouldn't it? My bad, ADB. Should be pi r squared, so pi a squared and half of that, right, because it's only a semicircle. Same thing for the area of BEC, pi r squared, so pi b squared, but only half of that because it's a semicircle. And then I'm going to subtract out semicircle ABC, so pi r squared, so pi c squared and half of that. And you're like, okay, fine. What's going to link this all together is the idea that this triangle, whenever you have a triangle inscribed in a semicircle, this must be a right angle. The inscribed angle is always half of its arc. So any triangle inscribed in a semicircle will end up being a right triangle. So no matter what triangle you inscribe in a semicircle, that's going to be a right angle. And again, it comes from the idea from geometry that an inscribed angle is half its arc. So all of these arcs are 180, so half of 180 is 90. So now that we have a 90-degree angle, we have a right triangle. And when we have a right triangle, we're thinking maybe some Pythagorean theorems going on. So, and that is what we have. So I know that a squared plus b squared equals c squared. And in this case here, I've got 2a squared plus 2b squared equals 2c squared. So 2a squared plus 2b squared equals 2c squared. So 4a squared plus 4b squared equals 4c squared. You can just divide out all the 4's, right? So you get a squared plus b squared equals c squared. And I see I have a squared plus b squared sitting right there. So what I'm going to do is leave this b, and then pull out the 1/2 pi from both of those, factor that out to leave me a squared plus b squared. And I can drop these parentheses at any time. They were just trying to set off the total area from that. I don't really need them. And so I've got a squared plus b squared, which I can now replace with c squared. So that's 1/2 pi c squared minus 1/2 pi c squared. And hey, those cancel. So the shaded area is going to equal the same as the area of triangle ABC. And that's that.